going to do a presentation of my final project for the class for making embedded system on claspert. And for my final project, I chose to do basically a door sensor that basically detect whenever a door is open and then send a command to a remote system that basically allow you to disable a switch. So if you look here in the picture, there's an LED. This basically represent an enable disable, and that will go to a larger subsystem and allow you to basically either turn it on or turn it off. So in this example, I'm going to arm the system using the arm button, which is the orange button in the picture. So when you press arm, you get an LED indication that comes on for a few seconds to let you know that the system has been armed, and then start blinking. And whenever it's blinking, it means that it's communicating with the remote system, which is currently armed. As you can see here, the LED is on, indicating that the remote system has been armed. And then if you look there, the green LED basically indicate that you're communicating with the remote switch over wireless protocol using the nrf24L01 module. And then now to demonstrate an intrusion. So basically right now, if you look here on top of the door, the sensor is basically sending a laser pulse and then bouncing back and then measuring the distance. And whenever that distance changes by 5%, it triggers a disable button, which basically cut off the circuit. Now, if you look here, on the right side here on the terminal, you'll see that there's a number that's incrementing up to 10, up to 8, and then back to 0. This is basically a heartbeat, and it's coming from the system on the door. And for some reason, if we lose that heartbeat, the remote system will basically disable itself, indicating that it's lost communication. So to demonstrate the first feature, I'm going to open the door, which will cause the LED to turn off. As you can see, when the door is open, the distance between the laser sensor, the time of flight sensor, and the top of the door changes, and then it basically triggers a signal to turn off the system. And when that stops, the command that's sent across to tell the remote system that it needs to disarm is a number 64. And whenever you press the arm button, it sends a 32, which basically said arm the system. So let's demonstrate that. All right, as you see there, a 32 is sent to the remote system, and then the LED turns on. So right now the system is armed, and the heartbeat is being set. So if we were to kill power on the system running on the door, it should stop the heartbeat. And elapsed time is 2 seconds. Lost heartbeat while system is armed. So basically, this is a message indicating that we basically lost communication with the system at the door, and as a result of that, the system disarmed itself as a security feature. Returning power. And if you return power, the first thing we do is we ensure that the system is in arm, so we reset it by default. This is a feature that I plan to improve for in the future. I should be able to just pull the system that's running the remote system and know the current state instead of just sending a command to disarm it. That way, you allow the user to see the indication that the system is armed, and they can choose to either enable it or disable it. So some debugging feature. Over here on the left side, we have an interface for the system at the door. Basically, the remote system that basically send the command across. And if you type the command, if you type anything, you get an indication. And then if you type enable, logging is enabled. And then if you type help, you get a list of commands available for debugging. So the enable and disable feature allow you to basically disable communication logging, so that you're not basically trying to write to the console when it's not running. And then you have the ver, which tell you the version information. This right now is a placeholder. Right now it's not implemented. And then you have the enable TOF, which basically enable debugging of the time of flight sensor. So if we do en TOF, and then we send the command. Right now basically it's enabled, but the way the system is set up right now, the state machine doesn't pull for data unless the system is armed. So as soon as we arm, then we start pulling the system for data. So if we go back here on top, and then we press the arm button, and the system is armed. If you come down here, then you'll see logging being sent out. So right now you're seeing the status 0 mean okay, meaning that we're currently getting good reading from the sensor. And then the distance, basically that's the distance between where the sensor is situated to the door, the top of the door. And then the deviation is a percentage that basically tells you how far away from the average you are. And this is what we're using to enable or disable the system. So with that being set up, so if I go here and I open the door, you see there a deviation of 15 is detected. As a result of that, the system is disarmed. And if you look there, an nrf24 command is sent to the terminal, indicating that the system has been disabled. And then if we come back here, we can do disable TOF. And then if you type that, the time of flight sensor logging is disabled. But I guess right now we're not polling because the system isn't armed, so you're not going to see anything. But let's type the help to see any other available command. So if you type help, and we have debugging for the state machine. So if we type enable STMC, then we're enabling basically logging for the state machine. If you look here, basically we're going through all the state in the state machine, and it's telling you which state it is in and what it's doing. So at this point, since the system is in idle, the only thing we're doing is we're checking RX, seeing if we're receiving any command from the console. If we're not, we go back to idle, and then we go back. Basically, we're alternating between idle and checking RX. So now that we have that enabled, let's go ahead and arm the system and see what happens. All right, so if you click enable, we're basically, right now, since the system is enabled, we basically get the state of ST arm, and then after we know that we armed the system, then we go to all the different transition events, which are basically pull for data from the VLX sensor and send a heartbeat to the remote system so that it know that it's communicating, and then check the remote console and making sure that we're receiving command to respond to command coming from basically the console, the command console. And we can do enable TOF. And then if you do that, then as you can see, right now we have both the time of flight sensor and the state machine transition being logged for debugging purpose. This is something I used while I was troubleshooting to kind of know where I was in the state. And then if we do several DIS okay. All right. Now we've cleared all the states, and that's it. I do have some future feature and stuff I want to add. Basically, like powering the unit off a battery, and then implementing a battery charger and better battery monitoring system, so that the system will be running and can monitor when the voltage drops below the operational voltage, and then can either shut down or send a signal to disable the remote command, the remote system. And I do have a lot of other low power features that I need to implement that I haven't got to yet. And that's it.